So I'm an engineer by training, and so I'm now in a science literacy role. So I work primarily through extension, so I was excited to hear Crystal talk a little bit this morning about what extension is, and I think Chuck's probably going to talk about extension too a little bit. So extension is an amazing secret that a lot of Nebraska doesn't know about, especially you guys in city campus. So excited to tell you a little bit more, and hopefully you'll get a better picture of what extension looks like. So today my talk, I'm going to talk a little bit about science literacy and our work over on East Campus and Institute of Ag and Natural Resources about our science literacy initiative. And then I'll wrap it up with some engineering design and kind of tell the story about how those two maybe not sound similar things are actually very tied together. There we go. So what does my life look like? My work life looks like this. This is a lot of the different projects I'm involved with, everything from robotics to wearable technologies. We work a lot with teachers. We have new projects that are working with high school students in Senegal. So working all really across the globe. If you want to be involved with any of these things, please talk to me afterwards. I'd love to get you involved. We need volunteers for all of these different activities, and it's a really cool way to get an idea of what's happening. But all of these tie into the Science Literacy Initiative. So science literacy is really directed at these 4 different groups. So we're working with partners in the community, so things like commodity groups, government systems. We're working with policymakers. We work with different public groups, so looking at the community at large, different producers or clientele, so a lot of what Crystal was talking about, working with those different areas. And we're also focused on higher education, so making sure that our undergraduate students are leaving Nebraska science literate. So what does that mean? I'll get to that next. So we're also working with PK-12. So we're working with younger students. So during James's talk a little bit ago, he was talking about what that looks like, how this 3D education, where we're really looking at applying what we know. So science literacy at Nebraska, if you go out and look for different definitions of science literacy, there's gazillions of them. What we're looking at here is how can people apply the science that they know to make decisions. So why is that important to us? If you think about Nebraska, you think about the world, right? What kind of decisions are people making right now? Clothing? Voting. Voting, yes. Voting decisions. So they're super important. Yes. Right, so they're voting about things. What kind of things are they voting about? Let's imagine that the November election presidential thing is quite as important. They're voting about policies, right? They're voting about what kind of things, do not pipelines go through Nebraska or not? Is that a good idea? Is that a bad idea? They're making decisions personally too, right? Making decisions about what to eat. They're deciding, should I feed my family GMOs? Is that a bad thing? Should I feed them organic? Should I vaccinate my children? All of these things really come back to these ideas of food, fuel, water, landscapes, people, all these types of decisions that we're really passionate about, especially on these campuses. This is a slide I love to show, and my students make fun of me because I put this in almost every presentation I do. This is an old slide now. It's from the ASABE, American Society of Ag and Biological Engineers. You can see projected to have an extra 2 billion people by 2050. That's an old statistic. I've heard anywhere up to 2040 now. We'll meet the 9 billion magic number, which apparently is going to be really cool and exciting because that's what everybody focuses on. It's not going to stop right afterwards. It's not going to just magically get to 9 billion at that point. It's going to be this continual growth. And what does that mean? We're going to need all these additional resources, right? We're going to have to feed those people, provide water for them. They're going to need energy to go about their lives. They're going to need health care. But we don't get a bigger world to do that, right? We have this finite planet, and we're limited by our resources. We're limited by the sustainability of our planet even, right? And so, like I said, I share this slide almost all the time. I showed this slide to a group of high school students at Lincoln North Star a couple of years ago, talking their engineering class in high school. I was telling this story about how this big problem we have is 9 billion people, and what are we going to do about it? And this guy way in the back, he raises his hand, he's like, this sounds like a really big problem. I'm like, well, I guess so. I mean, it's manageable, right? And he's like, you sound really excited about it. But it's a really bad thing. I'm like, well, thankfully I was on my feet that morning. And I'm like, I've talked to a lot of groups of students like you, and I've been in a lot of situations like this, and I know what you guys are capable of. And I know you're going to come up with these really This is your problem. And this is true. So I mean, part of our science literacy initiative is that we have to be preparing this future STEM workforce. These are big challenges, right? And so we need to be preparing these kids to go out and meet these needs. But along those lines, voting comes into it, right? And making sure that our society is really capable of handling these decisions. Personally, policy-making wise, all of this. And so we're really focused on what does that look like to make everyone capable of making these decisions. So the Science and Engineering Indicators is a really cool website. If you haven't seen it, they share all these interesting facts about what people know about science and what they think about different science news and things like that. And they put out this study where they ask different questions. So this is a little bit older audience. When I tell my undergrads this, they're like, I have no idea who Jay Leno is. But Jay Leno used to do jaywalking. Does anybody watch jaywalking? Where you go around and you ask all these questions, you show a picture of the president, and people are like, is that George Clooney? I don't know. And everyone would laugh. It'd be really funny. This is a scientific study that was basically jaywalking. So they asked these questions. Does the Earth go around the sun, or does the sun go around the Earth? Anybody have an answer? Which way? Oh, we know the Earth goes around the sun. So what percentage of people do you think said the Earth goes around the sun? About 73%. This was in the US in 2010, so a couple years ago. On a day-to-day basis, though, that knowledge really doesn't affect how you're going to make decisions really. When we talk about the cloning of living things, this gets a little bit more interesting. How many people do you think got this question right? Actually, a little bit more. And I think this is sci-fi, right? I mean, everybody watches TV shows about cloning and all of that kind of stuff. So people kind of understand that. This is the one that I think is the most interesting, though. Ordinary to maybe I get to read that. What's the right answer?
Of course they contain genes.
What percentage of people in the U.S. that they looked at, almost 2,000 people they asked this question to? 47%. So there's work to do. But what we're looking at is, I mean, this is content knowledge, right? This doesn't have anything to do with how a person's going to make a decision based on this knowledge. So they might know that all tomatoes are going to contain genes, but will that change how they're going to make those decisions about is genetically modified organisms okay? Do I want that in my food? So I think this all really comes back to what is science. Does anyone have an answer? This is a scientific kind of group. How would you define science? All right, so I went to Merriam-Webster. So it's the knowledge about or study of the natural world based on facts learned through experiments and observations. So it's really coming down to that experiments and observations part. So I like to think about the guys that are trying to tell what the elephant is, right? This old story about. So we're all looking at this little part. Everybody's studying their little tiny part, and then they're extrapolating it to, well, this is not how the world functions. And we're continually doing this, right? We're continually finding better ways to observe nature. We're continually finding whether or not it contains DNA. Because I don't want to eat DNA. That just sounds horrible. But when you think about the tomatoes, this makes sense, right? Of course you don't want to eat a tomato that has DNA or doesn't have DNA. It doesn't all contain DNA. It might be really bad. I don't know what DNA is going to do to me. I know DNA is something. And I know a little bit about cloning maybe. Maybe it's going to clone me. Or maybe it's going to do all these things. And so it really leads to this confusion. So I was thinking about all these things and what the problem is. And I'm an engineer. My background's all in engineering. So I was thinking, this is a lot like the engineering design process. Engineering design is just a way of making decisions based on a set of criteria and then choosing what makes the most sense based on scientific knowledge. Anybody know the engineering design process? Have they seen this before? I know a couple people have. It's on in here. Perfect. So we start with a problem. This could be how do I design a bridge, right, if you're a stereotypical engineer. Or it could be, should I vaccinate my children? And then you brainstorm solutions. You kind of look for some ideas of what knowledge is out there? What can I base my decision on? And you evaluate and compare those solutions. You want to make sure that you're not just choosing the first one you come up with, because a lot of pecans, my first idea is probably the best idea I'm ever going to have, right? And that's not usually the case. So we want to make sure we have a couple different ideas to compare. And we're not just going with our gut instinct, right? We have this set of criteria that's telling us what is good, what is bad, what ideas meet the constraints, which ones don't, and then we go through this whole process. And so engineering design can be a way of making these decisions. The American Society of Engineering Education has a K-12 division that holds a conference every summer that talks about how to implement engineering design, engineering practices in elementary, or K-12 school, really, P-12 now, into preschool. So along with that engineering design process, we're learning all these things, how to think about systems, right? Especially a lot of these decisions come down to how can I take information over here, and information over here, and bring it all into my decision that I'm making. It's not just about my gut instinct, it's not just about what my society is telling me to do. There's this scientific information here, there's something over here that this scientist is saying, and maybe I know this environmental impact, maybe I know this economical impact, and take that all together and make a decision based on that. Along with that, you get all these other cool skills that we want our students to have, right? We want them to be creative and optimistic. We want them to collaborate and communicate with each other. Think about ethics, because that's important. Along these lines, NGSS, again, if you were in James' session earlier, really focuses on bringing in engineering design. And I think this is really exciting because I'm an engineer, and I know the power that engineering design has. These are a little bit fuzzy. Can you guys see that? This is what they're expecting students to understand along engineering design. So they want to be able to define the problem, develop solutions, and then optimize their solutions. So this sounds great. This is what they're focusing on for grades K through 2. So when I think about my engineering students in college, sometimes they struggle with these things. So I'm really excited to see when students start coming through with all of these skills, and we can just build on top of that instead of starting from scratch. So it'll be an interesting process. But these are things that kindergartners can learn how to do, right? And so I think this is something that really can be applied society-wide. So how do we do this? And so I'm just going to tell stories most of the time. Which time? 1 minute. All right, I'll tell quick stories. So you can do this really quickly. This is an example of a really quick, one-touch kind of thing. So we can do Sunday with a scientist. We can do some things at the state fair. Or we're just kind of exposing students to engineering design. We can get a little more in depth. We can start developing K-12 curricula that teaches engineering design. So we have projects where we're teaching students how to design their own wearable technologies. So if anybody has a Fitbit or something like that, we're teaching 4th through 6th graders how to design their own, which is pretty cool. This is a cool project where I had my engineering students work with elementary education majors, and then they went and did after-school clubs. And so the elementary students were learning from my engineering students, which was pretty cool, because they realized that they didn't all look like Einstein, and they looked like normal people, and I could be a normal person. So that was kind of exciting for the elementary students. It also taught my engineering students how important it was for them to go out in the community and interact with people. And they started realizing that kids maybe don't learn as much science as they think they do in elementary school, and a lot of them were scared of it, and a lot of them were really excited to learn about it. So it kind of put little seeds in their mind that they're going to continue doing outreach. Now, this final project I'm going to share real quick, we did some workshops this summer for K-12 educators. So we had teachers come onto campus, and we taught them all these different biomedical engineering activities. So you see Nicole's over there doing a nanoparticle activity. We had alginate hydrogels, a little bit of tissue engineering, drug delivery type stuff. We were doing breaking bones, all these different activities. We gave the teachers a hashtag. So if you want to check out the hashtag in the corner, they were posting, and I was posting, we were all posting pictures during the trainings. And now that the school year has started, they're starting to post pictures of their students implementing these activities, which is super cool. But the biggest thing that I learned from this process was that teachers really want these experiences, and they really, really, really enjoy learning about our science. So if you can sit down with a teacher, maybe you did this last night, the speed dating stuff, and just share what you're doing, they will eat it up. And they'll think you're so cool, and they feel really cool. And that's another bonus. So we have time? All right. So want you to continue thinking.